Okay, so acids and base is something we keep hearing in Sec 2 science. You hear that a lot, you memorize a few things. Most people don't know what's going on at all, which is normal. When I was Sec 2, I also don't know what's acid and base. I only know acid has low pH, alkaline has high pH, water has 7 pH. All this basic stuff we know. I know that, oh, acid sometimes react with metal. I know acid sometimes react with carbon. But everything you know was at the very basic level, which nobody really explained fully what's going on. But now in Sec 3, whether you're pure or combined, you have to fully understand and memorize what you need to do for acid and base. So let's start first. The definition of acid is already difficult. When you read this definition, if you don't learn it properly, you actually don't know what's going on. What does it say? It says acids are substances that form hydrogen ions when dissolved in water. This is a keyword. Dissolved in water, which means all acids must be a solution. You can write down no water, no acid. Don't write this in exam. But what my point for you is, there is no such thing as a dry acid. There's no such thing as a piece of acid, because no water, no acid. Okay, there's no piece of acid, there's no acid gas, there's no such thing. It's either watery, wet acid in a solution form or none at all. And the proper chemical word for this process is called dissociation. Okay, proper word for this is called dissociation. Basically, what does it mean? Water has a magic power. It can dissociate, pluck apart a molecule to give you acid. Okay, later we'll draw some diagrams to explain further. But say again, water can dissociate acids, and therefore we have that's the birth of acid. That's the very meaning of acid. It was plucked apart by water to form H plus ions. Okay, y'all can be a bit lost now, no worries. Later we'll see more. Okay, we'll skip the strong and weak part first and go to the empty spaces to draw stuff. Okay, now, we just finished bonding chapter, so all of you should be quite fresh in your memory what is a covalent and ionic bond. Wenxuan, are you familiar with covalent and ionic? No, just say no, it's okay. Okay, HCl, can you look at all your periodic tables? Hydrogen, is it a metal or non-metal? And Wenxuan also can look. Hydrogen is the top guy. Do we all know that hydrogen is a non-metal? Would you know? Non-metal. Sorry, just in case she is a bit lost, let me just show a bit more. Where is it? Periodic table. Yeah. Okay. This is the periodic table. Wenxuan, go to your periodic table and add this thing in. There's a line here. Have you seen this line before? Draw this out, and basically everything here is metal. Those of you who have been with me but still not sure, you can also do this. Non-metals. Why do I make it so, exaggerate my drawing and draw all the lines around? Because a lot of people thought that hydrogen is metal. It's quite believable that hydrogen is metal, because it's kind of on the left side, it's kind of on the wrong side. But hydrogen is special. Hydrogen is not metal. Just remember that. And hydrogen is right there because it's a bit weird. Later we'll see how it's a bit weird. But anyway, this one okay, right? Metal, not metal. This one must know. So go back to the notes. Hydrogen, you can just tell me right now. Non-metal. NM . Chlorine. All of you should know where chlorine is. Chlorine is non-metal also. So non-metal plus non-metal must be what kind of compound? Must memorize. Which if you didn't know, you can memorize now. Anytime non-metal merge together, we call it a covalent compound. And hydrogen chloride is a covalent compound in gaseous state. When it's gas . Okay, why am I emphasizing this gaseous state? Because a lot of us might already know HCl is an acid. Maybe you hear from Sec 2, maybe you hear from your class recently, last week or this week. You already know HCl is acid. But what did I just say? earlier when we introduced this chapter. No water, no acid. So if I give you gaseous HCl, is it acidic? No. It could be acidic if I later do something. What do you think I'll do to it? Give it some water, throw in the water. Haven't thrown in the water, is it acidic? No. Okay, so be careful. Haven't thrown in the water. Hydrogen chloride, how to draw dot and cross diagram? For the sake of Wenxuan, she's new. So I just quickly show you all hydrogen has 1 electron. Chlorine has 7 outer shell electron. Wenxuan, would you know all of this? Do you know how to determine how many electrons each guy have? You know, hydrogen has 1 electron. Chlorine is group 7. It has total 70 electrons. You know how to configure 70? 2, 8, 7. You know what that is? So inner shell has 2, second shell has 8, third shell has 7. So if I drew the outer shell like that, I haven't drawn the dot across yet. So I'm trying to merge them. We just had this lesson for last 2 weeks. So to covalently bond them, I'm just continuing the color code. All must draw this. This is HCl covalent molecule, covalent compound. And it's resulting from a H atom and a Cl atom covalently bonded together. Can somebody tell me again what makes something covalent? How do I determine whether 2 atoms interacting is covalently bonded? Non-metal. Okay. Now, this is not acidic yet. You all look down. What am I doing? When you dissolve it in water, it will fully dissociate. That means water has the magic ability to go and grab your HCl and do what to it. The proper word is, I don't know, the scientific word, the chemistry word is no, dissociate. Water will dissociate, but you think of it physically, what is dissociating? I am holding it and plucking into 2. After I pluck it into 2, now acid is formed. So you all can, this diagram is a bit blurred, but you all can see this is our HCl molecules. Molecules means they are covalently bonded. Haven't touched water yet, huh? I throw into water. Now, what happens to them is water will force the H and the Cl to separate. What's the proper word to say they separate? Dissociate. It will dissociate into H plus and Cl minus. So now, how do you draw H plus? H plus means a hydrogen. Okay, this is a hydrogen atom. Plus means what? I lost electron. So no more electron already. Just like that. Okay, it used to be like that. It used to be like that. H is the electron of its own. Hydrogen has 1 electron. This is gone. After it's gone, that's why I see the whole shell has nothing. And then, would you know, losing 1 electron gives you a plus charge. Yeah. So this is the H plus electron, ion. A bit weird, nothing to draw, empty. So do you know, quite interesting, hydrogen has how many electrons, originally here, has how many electron, how many proton, how many neutron? You can draw this hydrogen atom. This is cation, different. I just want you to tell me, the original hydrogen has how many P, how many E, how many N? This one we learned it 1 month ago. Look at the periodic table. 110, very, very good. So what does the hydrogen cation has? How many E, how many P, how many N? You can reference from here, because I lose the electron. These two usually cannot touch it. P and N cannot change it. 0, 1, 0, 1, 0. So actually in JC, a lot of times we are lazy to say hydrogen cation ion, 6 syllables. You know what we call it? just a proton. This is a proton. Actually, is just a proton. And this one, I didn't come out with it, we verified it ourselves, you see. We did the math, we found out that it's just a single proton. Does it make sense? This is what you want to know, but it's just interesting. So a lot of times in JC, we just call this a proton. But to make you less confused, because you'll be, how come where the hydrogen go? The hydrogen disappear, or then to not confuse secondary school kids, we continue to call this a hydrogen cation. The full name is called hydrogen cation. But technically, it's just a single little what? It's a single little proton. So it's quite interesting to think about that. Now, a chloride, just now we already draw a regular chlorine, has 7 outer shell. 1, 2, 3, 4, 5, 6, 7 outer shell electron. But he has received the donation of 1 electron from the hydrogen. So I put a red cross here. And overall, he becomes a negative charge. Because gaining an electron that don't belong to you. This electron came from who? And he donated him so that hydrogen himself is stable. Chlorine also got stabilized. This is called chloride anion. And both became stable. This is hydrochloric acid. Okay, so this is very confusing because one chapter ago we say non-metal plus non-metal should be covalent, but now one chapter later we tell you it also can be ionic. So hydrogen compounds is very confusing. It can be covalent, it can be ionic. What is the difference? What is the difference between covalent and ionic? What is the one thing that one environment change between the before and after? The fact that HCl has thrown into water. Water is the deciding factor. Water, so dry HCl is what bonding? Dry HCl, covalent. Wet HCl, yes. A little bit weird, a little bit not the same as what you thought you knew because we learned it a bit differently during bonding chapter. Just get used to it. This is the dissociation of HCl. Okay, cannot. This is important, and I don't think anybody will teach it in school. This is a bit weird, and a lot of teachers just skip through it. They just ask you to memorize. Now, also must memorize. Strong acids fully dissociate. Weak acid partially dissociate. So dissociate, just now I told you, is the act of tearing it into two. My HCl tear into H plus Cl minus. You know, by the way, they all know, is it the H plus or the Cl minus that is really the acid? You think about it. Just like I told you, HCl, you can look at people on my screen. HCl got torn into two, into H plus and Cl minus. Who is the acidic part? Which part makes it acidic? H plus or Cl minus? Look back at the definition of acids. The fact that it contains H plus ions. Okay, so it's the H plus that makes it acidic. So the chloride, not important. It's there, but it's not important. The sulfate is there, but not important. The nitrate is there, but not important. What makes acid acid? The fact that it has H plus. Okay, just remember that. Anyway, I haven't explained enough. What is full dissociation? I mean, you can contrast the two words, full and partial. Full means absolutely 完全 totally dissociate. Partially means, I mean, you guys know English. Partially means some of them get dissociated. So what makes a full acid? These three acids you must memorize: hydrochloric, sulfuric, and nitric. They are all considered fully dissociated. So they are strong or weak? Are they strong or weak? Very strong acid. Why are they strong acid? Because the bond is very weak. The H plus and Cl minus, when you throw in the water, easily can split. Which means, let's say, I give you, pretending 2,000 pieces of H plus, 2,000 pieces of HCl. 2000 is just a random number. I throw into water. How many H plus do I get into water? What do I get? Now that you know that they fully dissociate, that means every single last piece of them will split. Huh? How many? 2000 what? H pluses and 2000 Cl minus. This is a numerical example of full dissociation. 一个都不剩, right? Nothing left. Can split, will split. All of them will split. Anytime it will fully dissociate, I call this a strong acid. How many strong acids are in your syllabus? 3. Memorize them. Memorize the 3 strong acids. Okay, this 2000 is not, doesn't matter. I can put 5 also then. 5 of them will become 5. 2 million of them become 2 million, right? So they all will split. Please split to split. Okay, memorize the 3 acids. CHCl, not just the English name. The English name must memorize. The chemical name also must. HCl, H2SO4, and HNO3. Okay, this one, weak acid, no need to memorize. But who can use my example to carry on explaining what is partial dissociation, what is weak acid? How do we know something is a weak acid? Since I told you, strong acids will 100% totally dissociate. Weak acid, right? You don't get full. Let's say, pretending I throw 2000 vinegar. Pretending lah. And I told you vinegar very lousy, only 10% dissociation. What does it mean? And don't use 2000 very hard. I use 100 pieces of vinegar. Okay? Just another numerical example for you to see what's going on. 100 units of vinegar you put into water. And I told you this guy is only capable of dissociating at 10% level. You know what happens? Then you get 10 plus, 10H plus, 10 of the other anion, which we don't need to know what. Because just now I said Cl minus, we know it's 7, but this anion is big complex. You will learn in Sec 4. But I will still have 90 vinegars. I mean, there's no such thing as vinegars. I'm just telling you, when it's a 10% dissociation, what does it mean? 90% remains undissociated. It doesn't have to be 10 is so random, it could be a 50% dissociation. But you can understand that the lesser the dissociation, the weaker the acid. Right? Because you look at the number of H plus that's formed. Not a lot, huh? If I give you 100 pieces of nitric acid, yeah. If I give you 100 pieces of nitric acid, what happens to all of them? 100 pieces of nitric acid. 100 pieces of H plus, 100 pieces of this anion. So, how now that we understand this, how do we measure the strength of acid? Literally, we're just measuring the concentration of the H plus ions. 越多越好 ，not 好啦，越多越 toxic 啦。You know, acid can burn you. The more H plus, the more dangerous it is, right? And the lesser the weak, the easier lah. So that's why vinegar can drink, Coca-Cola can drink, right? They don't kill you. You drink HCl, you might just die, right? I don't think you'll die, like you'll be in trouble. Okay, strong and weak acid. Are you all okay so far? I'm going quite slow because this is really hard to understand. Really hard to understand. Okay. Sorry, I need to say one more thing. Help you all remember how to memorize these 3 acids. Those of you who are diligently memorizing my 5 polyatomic ions, who did already? Honestly, haven't just say haven't. Haven't. No. If you already put the effort to memorize the polyatomic anion, you already know a sulfate is SO4 2 minus. So a sulfuric acid is just a sulfate crisscross with a H plus. Have you learned the crisscross in school? Okay, so to crisscross this, the numerical 2 comes here. The numerical, what's the numerical here? When I write plus 1 goes here. So if I crisscross H plus and SO4 2 minus, I get sulfuric acid. So do you really must you really memorize H2SO4? I don't think so. You just need to continue memorizing your SO4 2 minus because your concept already told you H plus is the guy that causes acid to be acid. So 跑不掉, you must have H plus. No H plus, no acid. H plus and a spectator. In this case, my spectator, I choose sulfuric acid, sulfates. Sulfate, crisscross, H2SO4. We try again. Nitric acid. I already know H plus must be present. Nitric acid, you must memorize nitrate. NO3 with the minus. If you already memorize nitrate, don't you think you can figure out nitric acid without studying? What is it? Crisscross the ones. Right? This is one, go here. One, go here. Become? Exactly. So nitric acid need to memorize. No, you should actually memorize nitrate. Sulfuric acid need to memorize. No need, you should memorize sulfate. There's even one that we don't learn, not in syllabus, but let's try. If I want to ask you what is a carbonic acid, you use some common sense. It is H plus with who? One of the guys I told you to memorize. Carbonic acid sounds like you need what anion. Then you have to memorize this. One of the 5 that you have to memorize. Anybody? Quick. Online also can tell. If I ever ask you for carbonic acid, which is not in syllabus, but I want to show you carbonate. Kelly is right. Carbonate is CO what?
3 2 minus.
Very good. So if you ever need to write a carbonic acid, you can. What is the carbonic acid formula? Crisscross yourself. The 2 go down, the 1 go down. CO3. So you just made up your own carbonic acid, right? Let's try another one. Not in syllabus. I don't know how to spell, whatever. Phosphoric acid. If you ever need to do phosphoric acid, not in syllabus, but you know it's H plus crisscross with. Not, you don't need to memorize, but it's in my notes. Phosphate. You see? Who can tell me the formula for phosphoric acid? Exactly. So it's powerful, Your crisscross skill, if you apply it correctly here, you can memorize all 3 acids without too much effort. And trust me, you must memorize this all day, every day. Okay? Are we okay? Hannah? Now, introduction to base. Bases is even harder to understand. I'm very sorry. First page already very heavy. First 2 pages taking a lot of brains already. Memorize the definition. Bases are metal oxides and metal hydroxides. Which means you just need to happily go to the periodic table, grab a random metal, you crisscross it with oxide, that's a base. You happily take a metal, crisscross it with hydroxide, which is OH minus, that's the base. Which means you just look at a periodic table over there. You can easily come up with 50 bases because there are so many metals and all of them can crisscross. I'll give you an example. If I want to play it safe, I use lithium. Is lithium a metal? Can you find lithium? Lithium is a metal, it's a group 1 metal on the left side. We'll just look at the left side, group 1. Lithium is a Li plus. Can I make 2 types of bases out of lithium? I can, because I just need to either crisscross it with oxide or crisscross it with hydroxide. Let's try oxide. If I crisscross lithium with oxide, what is the outcome? Li2O. Would you know it's Li2O? This is a base. What if I want to be lazy? I don't want to make another metal. I still stick to lithium. I change to hydroxide. I crisscross lithium, hydroxide. Would I get a base? I will, because the definition is very broad. The definition of bases is very broad. Just anyhow take a metal, anyhow crisscross with oxide and hydroxide. So what is the crisscross of lithium hydroxide? Hey, so easy. LiOH, is that a base? It's definitely a base. I give you another example, the rest you'll do yourself. Okay, enough with lithium already. I want to try something fancy. I want to try aluminum. Can I try aluminum? So what is the outcome of aluminum crisscrossing with oxide? Online very quiet today. You all can contribute a bit more.
AR2.
Very good. Al2O3, is that a base? Definitely a base. You all know where I'm going already. I'm going to try aluminum hydroxide. Somebody again?
ALOH3.
ALOH3. If you write like that, we'll get wrong.
Bracket.
Sorry?
Bracket.
Bracket the OH. Why? Because I'm taking 3. Which way following? I need the 3 to multiply by the OH. So the OH must be bracketed. So no bracket, you lose marks. Okay? Y'all can make 6 more examples. Free and easy. Very easy. Really up to you. Anyhow, take a metal. You can be weird. You can take those francium, beryllium, all those. All can. Magnesium, zinc, lead, silver, all can. You choose whatever metal. You want to use americanium, you dare to use, you can use. You know? It really doesn't matter. Just crisscross with any oxide, hydroxide, you are fine. Okay? No need to send. I'll just walk around and check. This is simplified. Oh. Keith wanted magnesium oxide, so he went with Mg2O2, but I told him it's wrong lah. Cancel the 2, so it's MgO. If you want magnesium oxide, you can MgO. Be, if you use beryllium, beryllium is group 2. Right? Group 2O is also O2 minus, so you can also working Be2 plus. Next to it, Be2 plus. Be is the top right 2 plus, because group 2 will have a plus. And next to it, you write O2 minus. This is the working one. O with the top right, no, top right 2 minus. You crisscross. The 2 went down, the 2 went down. So it's opposite, it's Be2O2, but 2 and 2 can cancel. So what's the answer? BeO is beryllium oxide. You can do BeO. So this crisscrossing thing we'll keep doing in this chapter. You must get used to it. So why don't we try something else? We try to make calcium hydroxide. Yeah, just do working. Calcium is group 2, check already. So it's Ca in the top right 2 plus. Hydroxide is on my notes. It's OH in the top right minus, which has numerically 1. So 1 goes here, 2 goes there. So the answer is Ca bracketed OH2. This is calcium hydroxide. Right? You play around with that. Okay. If you have issues, you can ask me. If you're not sure whether your answer is correct, you can send. But otherwise, I think we should be fine. Wow, SB, I don't know what SB is good. SB group 5, how to? Oh, you're so fierce. She really go here. Like, very adventurous, I respect that. So let's do it 5. So we pretend it's 5 plus. I don't know whether 5 plus is 5 plus. Okay, a bit too adventurous. Yeah, I'm not blaming because I say okay, but this one is on the verge of non-metal. It's just like aluminum. So a lot of times we don't mess with this guy because sometimes the property change. I mean, this one I haven't taught, so it's not a part. So let's be a bit more confident. This is a bit to actually. So you go back nearing here. You can try your Fe2 plus, you can try CO2 plus. But this guy, sometimes the property change. So I was hoping that we can try with SP5 plus. But I also don't know whether it's a real thing. So that's not. It's okay. So just hold back on the adventure, being adventurous, and then but it's not a point. I might potassium oxide K2O definitely can. Beryllium oxide BeO definitely can. And anybody, if you're not sure, you totally can send it and ask me to check. Okay. Is this okay? FeO, is it okay? Yes, no, or don't know. So how come it's a bit stressful? Fe, because you cannot check its charge until you memorize it. Right? So if you don't memorize, you won't know. But can lah, because Fe can be 2 plus. Like that can. Also can. This one I'm crisscrossing Fe 3 plus and O2 minus. So Wenxuan might be a bit confused, but what I told them is like charges of iron have to memorize. Can be 2+, can be 3+. Just like charge for Ag must be. I'll never memorize that. Ag must be memorized. So all this stuff, soon I'll tell you where to look out for. But all this can. If I can go on, raise your hand. Okay, very good. Now, having a broad introduction to bases, I first want to tell you there are many bases. I can easily count 30, 40, right, of them. Now, what is one characteristic of all bases is they will neutralize acid. This one you all probably already know in lower sec. It's like yin yang, you know yin yang. Yin yang, boom, become nothing, you know, like black and white, boom, become, you know, they cancel out each other. Acid and alkaline also have the effect. Acid can kill you. Alkaline can kill you. Both are dangerous. You know that? If you drink detergent, you think you die. Yeah. If you drink sulfuric acid, you also die. You pour them together, what do you get? You get something, the purest and cleanest possible thing. What is it? It's on the notes. When you mix acid and alkaline, which are both toxic and destructive to you, you actually form something very nice. What is it? Second, yeah, it's right here. Salt and water. Right? Salt is salt. Water is literally water. It's literally H2O that you can drink. Of course, some salts you cannot drink. But my point for you is, you turn something that are both extremely dangerous to you, you neutralize. Neutralize means what? You cancel out the effects. It's no longer harmful. You get nice, pure, clean water. I mean, it's not pure water because of salt, okay? But my point for you is, from extremely harmful to chill, all good, okay? This is the nature of the opposite natures of acid and alkaline. Now, I'm already starting to use the word alkaline, although I have been using the word base earlier. Most people don't understand the difference between alkaline and base. Okay? Just read this sentence. Bases are mostly insoluble. Insoluble means what? Cannot dissolve. If you didn't know, just right now. Can dissolve in water. Give me the one example of something that cannot dissolve in water. Sand. So just think of sand. Most bases act like sand. You pour into water, you stir it up, you know what you get? A mixture of sandy water, right? Now, that's why it is very hard to come by. When a particular base can dissolve in water, it's very rare and it's very sought after. That means we love it. And we love it so much that we give him a new name. What do you think is the new name? Every time a base, because most base cannot dissolve. Whenever I find a base that can dissolve, I'm very happy. So happy that I invented a new name for it. Alkaline. Okay, so alkaline is what? Alkaline is bases that are soluble. Soluble basically no need to write already lah. You know, it means can dissolve in water. Which means I take an alkaline, pour in the water, stir it up. Do I get sandy water? No, you get a solution, colorless solution that is called alkaline. Okay, and there are only 4 alkalines in your syllabus. I mean, there are more than 4 in the world, maybe a few more, but not many more. In your syllabus, later I'll teach you how to memorize sodium, potassium, calcium, and ammonium hydroxide. Later we'll memorize again. Just tell you there are 4. Okay? Everything else, we cannot call it alkaline. Alkaline is a special term. It's a term of prestige. It's very difficult to get alkaline. If I show you this guy, would you consider him alkaline? Probably not. But you can test. How do you test? Throw into some water and stir. Probably aluminum oxide will remain as aluminum oxide. So all I can describe aluminum oxide as is it is a base. If I throw, I think lithium hydroxide actually is an alkaline, but it's not in syllabus. If I throw lithium hydroxide into water, stir after a while, no more already, disappear. I can call lithium hydroxide alkaline. Right, so there's a solution. So it's a bit similar to acid. Just now we said that acid, to be acid, you must put in water, dissolve, let it dissociate. Actually, it's the same with alkaline. Imagine there's a piece of sodium hydroxide. you dump it into water, water can dissociate it and it goes through a full dissociation. So it's very similar. The stronger the alkaline is, the more soluble it must be. Does it make sense? The more soluble you are means the more easy water can split you into your OH minus and maybe Na plus. So same logic as strong alkaline, strong acid, weak acid, strong alkaline, weak alkaline also compares the ability to dissociate. Fully means 100% dissociation. Partially means maybe 30-40% dissociation. So same thing, to make a strong acid, I want plenty of what? Plenty of what tells me that I'm having a strong acid. Last page. Plenty of H plus. Plenty of H plus means this acid is wow, very powerful, very strong. Plenty of what tells me I have a strong alkaline? OH minus. OH minus, hydroxide. Okay? And the beautiful thing is, later. Beautiful thing is, H plus and OH minus actually is, think about it, H and OH. It's actually, that means what makes acid acidic is H plus. What makes alkaline alkalinic is OH minus. When you merge them together, you get what? Then you get water. No need to copy. This one I got print as a later page. You get water. Right. HOH ma. Right. No need to copy, Okay. Now, this red box, I also find it very hard to remember. Also, the schools, the teachers really don't teach a lot about this. I really hated it. When I was young, I didn't know this until I was a teacher. Okay, which means when I did O-level, I also got some wrong. Solvents. Solvent basically means what you use to dissolve solutes. You remember this from lower side, right? If I put sand, if I put salt mixed in water, who is the solvent? Who is the solute? Yeah. So this is from lower side. So understanding in chemistry, there are only two types of solvent. That means I have two types of things that can help me dissolve other people. They can only either be organic or inorganic solvent. The two categories are organic and inorganic. Okay. For simplicity, for O levels, inorganic solvent literally means water. Literal water, H2O. Okay. And sorry, I found the sentence not complete. Maybe kind of block. Okay. And any other solvents named in the question. Sometimes they give you weird name. Dissolve in hexane, dissolve in benzene. You know, weird names that you never see it. Sorry, the words are blocked, but tell me if you feel that. Are considered non-organic. Sorry, inorganic say already. I consider organic, I consider organic. So I told you there are two types, organic and inorganic. So if I say water, I'm referring to what kind of solvent? Organic or not? Water is inorganic. Benzene is, I give you a weird name. Butyl metanoate is organic. All the weird names are organic. How come I want to emphasize this? Because acid and alkaline, they only love to get dissociated by inorganic solvent. Simply put, only what can dissociate acid and alkaline? Only water. Can I put oil? Can I put sweat? Sweat got water. Can I put alcohol? Can I put, you get my point. Why am I saying this? Many questions they will say, HCl is dissolved in benzene. What happens to the pH? Half the kids will put 1 because they thought HCl is a strong acid. You all know pH 1 to 14, right? So they will get tricked. I say HCl is dissolved in benzene. What is the pH? 1, 14, or 7? Y'all can guess, online people. Hello. Oh, what's the difference? HCl is like this. I'm trying to make it look like this. HCl is dissolved into benzene. Then they ask you, what is the end product? Is the end product acid, alkaline, or neutral? Neutral, because benzene is not water. So only water can help you dissociate that. What does it mean? That means all the HCl go into benzene, what happens? No, benzene is trying to be the solvent. That means benzene is trying to dissociate it. But can benzene do it? Cannot. So all the HCl go into water becomes unchanged. Any dissociation? Are you forming any H plus? So what is the pH? 7. 7 means neutral. So I say again, trick questions will try to make you think like you are having dissociation. But as long as you remember, only water can dissociate. If I say NaOH is dissolved, NaOH is the alkaline here. NaOH here. NaOH is added into oil. What is the final pH? 7. Nothing happened to it. The NaOH sits there as it was. Nothing happened to it because I need water. No water, no acid, no water, no alkaline. Right? So this is why I put in this last little box here to remind yourself. Sometimes they can, not supposed to ask because it's a bit out of syllabus, but they will ask you about the concept of organic and inorganic solvent. So what you must remember is I only need water, and water is considered what kind of solvent? Inorganic. So everything else is organic. Okay, you will get questions like that. Okay, this next page is easy. It's all lower sex stuff. So I just want to remind you, it's quite interesting. Water, nice and pure. We drink it every day. If water dissociates, water partially becomes a strong base, partially becomes a strong acid, which is quite interesting. It's quite interesting. So it's here in a normal cup of water. When you drink it, do you think it will taste like acid or alkaline? But actually it contains this, it contains OH minus and H plus. Then how come it tastes so nice and harmless? Because it has the same number of H plus and OH minus. So the number is you're kind of right, neutralized. So kind of even out. Which means if I give you a water but has excess H plus, this whole thing should be more acidic than alkaline. If I give you a same cup of water, but I give you more OH minus than H plus, this thing should be more, is it neutral? Yes, more OH minus. So it will be more basic, that's the word, or more alkaline, or more alkalitic. So what am I trying to say? The pH of the water actually depends on the ratio. Okay, on the ratio of H plus and OH minus. It's all here. So the pH scale, it depends on the ratio of H plus and OH minus. If I got equal amounts of H plus and OH minus, pH is 7. And have you heard the universal indicator? The universal indicator is a testing, it's a solution that tests for you whether it will change color accordingly. So if I drip it into water, the indicator will show green. If I drip that into a lemon is acidic, it's very sour. It will be orange, and then I can compare. There will be a color cut that I can compare. It's orange, so it must be pH 2. If I drip it into bleach or soap, it will turn purple. And how deep the purple is will tell me how strong the alkaline is. So how do you remember? 7 is in the middle, 7 is neutral. So there must be same H and OH. Less than 7, anything less than 7 is considered acidic. So pH 6. Milk is actually, I didn't know this also, but once I see this table, we can say that milk is a little bit acidic. Baking soda is a little bit alkaline. Okay, so it's just comparison. So 7 is the benchmark. Less than 7 is acidic, more than 7 is alkaline. We are always comparing who do I have more OH plus or more OH minus. Because we still must remember H plus is what makes acid acidic, OH minus is what makes alkaline. Okay? And that this question on indicator also learned in lower sec already. What does it mean? You no need to memorize anything. No need to memorize. Okay, right now. So in case for exam, you don't go and study excess. These are 4 chemicals. There are definitely more than 4 in the world. There could be thousands. Okay, but we have this 4 example. What does it mean? When it is in acid, he will be in this metal orange he will be showing red. Which means if I buy a container, a bottle of metal orange, I can drip it into things. If I drip it and it shows red, that means this thing is, the thing that I just dripped it into is acidic, because metal orange will be red in an acidic condition. If I drip it and it shows yellow, that means this thing I'm testing is alkaline. Right? So these indicators become like our testing method. I drip metal orange into an unknown substance, I can roughly tell whether it's acidic or alkaline. I drip bromothermal blue into another substance. If it shows blue, it must be alkaline. If it shows yellow, it must be acidic. Okay, and so on and so forth. So these are 4 examples, no need to memorize. It's interesting because they all can change at a different pH. That means 4 is the for metal orange 4 is the changing point. If I drip it into pH 1, 2, 3, it will show what color. If I drip metal orange into something that is pH 1, 2, or 3, what color will I see? Red. If I drip it into pH 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yellow. So the changing point is 4. If I use bromothermal blue, the changing point is 7. Below 7, which is 1, 2, 3, 4, 5, 6, it will show yellow. 8, 9, 10, 11, 12, 13, 14, it will show blue. So they can have a different changing point, but because it doesn't matter, if I'm testing for something very acidic, the pH should be near 1 or 2. If I'm testing for something very alkaline, the pH is near the top, 13, 14. Right? So despite the color change at a different pH, it generally still works. Okay, so these are indicators. Okay. Today, let's try to go until finish this page. If you can, it will be quite impressive. So just now, honestly, the first 1 page is just an introduction of how acid come about. Now we have to study what is acid. Same thing, the first sentence already mentioned, no need to say again. 3 acids that you must memorize. You must use your life to memorize it. I already taught you how. You just need to get better at it. There's 2 new words, monobasic and dibasic. Okay? Based on my notes, who can make a guess? What am I referring to? Monobasic, I mean the definition is there, and I'm saying that HCl and HNO3 are monobasic. Yeah, one H. Then sulfuric acid is a bit special. It is called dibasic because it will have. So who is the strongest acid? The strongest. Because it makes 2. How do I see 2? Here. Right. 2. So 2H plus referring to the H2SO4. Strongest 越多越好嘛, right? H plus. Now, properties of acid. This one usually people don't struggle here. It's easy. Memorize every single dot. All acids are sour. All sour is acid. I know it sounds a bit weird, but really, everything that tastes sour is acidic. Coca-Cola is acidic. Lemon juice is acidic. You eat your lor mee with vinegar is acidic. Right? But of course, some like just now milk is not sour. Milk pH is 6 plus, so it could be low enough such that it's not like neutral enough that it doesn't taste sour. But anything that tastes sour must be acidic. Litmus paper is just another type of indicator. Litmus paper can exist as 2 colors. It can be blue or red. It is the same substance, but it can be blue and red depending on the condition. So what you do, you go to the chemical store and you buy blue color litmus paper. And this is a literal piece of paper. You can dip it into different solutions. If the blue remains blue, means nothing happens to it. If the blue turns red, means whatever I have dipped into is acidic, right? So can I go and buy red litmus paper? You also can. There are two types of liver paper. It's the same substance. It's just sold in a different condition. That means the blue liver paper already come in alkaline condition. You dip it into acid. If it turns red, that means it's telling me this thing is acidic. Later we'll see red litmus paper. So litmus can be in blue or red. You dip it into things and whether it change or not. So what if I take a blue litmus and I put it into this water? This pure water pretending. What happens to it? It stays blue because it has no reason to change. Because you only can take two modes, blue or red. Some kids will tell me turn green. You know why they thought turn green? They confused with universal. Universal is the rainbow. Universal is the one that gives you colors of the rainbow. Litmus paper can only show red or blue. So a blue litmus, when it turns red, means got acid. If it stays the same, means no acid. But no acid means what? Is it alkaline or pure water? We can't tell. No, we can't tell. Because if you take blue litmus and dip it into alkaline, it also should show blue. So when it remains blue, how do you know whether it got change or no change? We can't tell. Right, so litmus test is just blue or red. The third bullet is really no big deal. It is aqueous solution, basically means dissolved in water, and it must have H+. We keep saying this over and over again. H+ is the main idea of acid. Now, the last one is hard. The last one is hard because you need to have strong concepts in bonding. All acids are electrical conductor because who can correctly tell me when we learn bonding? What did I say? You need two conditions to be electrical conductor. To be electrical conductor, you need either what? Say again? Mobile ions or mobile electrons. This one maybe Wenxuan must write down because the rest of you have written down this one 2 or 3 times. But no harm writing again. To conduct electricity in chemistry, I must have something moving. Move, then can help me carry charges. If everything is stationary, the charges come to you, you cannot bring him anywhere. So I need ions to be free, or I need electrons to be free. Then that exactly fits the description of acid. Why? Because acid says that when HCl jump into water, the water split it into ions. Are these ions bonded in any way, or are they just floating around? The H plus Cl minus, for example. Remember, water did what to acid? Water dissociated them. See? Can see the diagram. It's very blurry, but you can see what I'm trying to say. They split up, dissociate. Are they bounded together by anything? Or are they just free to float around? They are free. So these 3 guys, no, these 6 guys, all of them, can they carry charges? Can they help me conduct electricity? Can. This one can conduct electricity? No. This one can conduct electricity? Yes. So after dissociation, the HCl gonna plug into 2. Is there anything holding them back? No, not anymore. So they are free to float around. When they are free to float around, they are conductors. Okay. Understand? So last properties of acid must memorize. So okay, I try my best to do a bit more, but no big deal. So 3 characteristic reaction of acid. That means acids will always react with base. Acids will always react with metals. Acids will always react with metal carbonate. Always. Which means there's a lot of memorizing to do. If I give you any acid, I react you with any base, you will give me a salt and water. We look at the example. H2SO4, one of the 3 acids you must memorize. I wanted to react with a base. In this case, I chose a sodium oxide. Is sodium oxide a base? You must quickly think. How do I know whether sodium oxide? Because if you don't even know whether it's base or not, how do you know what reaction it will take place? Is it a base? Why is it a base? Because it's a metal crisscross with metal crisscross and non-metal is always a base. Base. So anyhow, sodium chloride is a base. First thing about definition of base, any metal oxide, metal hydroxide are bases. So it is a base. You must know what nature it is first. So now that I know this is a neutralization, I can go and write water will come out. Okay? And the salt, how do I know the salt? See, this is how we do it. You take the metal from the base, you take the anion from the acid, you go and crisscross yourself. The salt is just a mix and match of partners, you see? The H and the O becomes water. So what have you not used? You have used up H and O already, you haven't used Na+, you haven't used SO4 2-, so they must crisscross together and give you this product. This is how we come up with the chemical formulas for everything. Okay? This example is printed, so what do you do? Then we need to do a balancing. Balancing means you must count the atoms on both sides to make sure they tally. Can somebody tell me, on the left hand side, how many sodium atoms can I count? That means how many pieces of sodium? On the overall left hand side now. Here got how many sodiums? Na. 2. Here got so many, how many sodiums? 2. So Na is done. Here total got how many oxygen atoms? Count properly. 5. Can see 5? Here got how many oxygen atoms? 5. O4 means 4个 O. O means 1个 O. 5个, right? How many H's can I count overall? How many H's? Okay. How many sulfur? Sulfur only 1. So is this mathematically balanced? Numerically okay? This is the balanced equation. We'll try one more. I'll make one. I think for y'all, before we dismiss, y'all make one on one. So I want to try another acid. I have already memorized nitrate, NO3-, so I can easily write down nitric acid. Bracket AQ, because you don't know what is AQ? Aqueous means dissolved in water. All acids are aqueous, no other way. Then I'm trying to come up with a base. Can you give me a cool base? One of the ones you did also can. You did many, but you did 10 of them. Can you give me one? So hard. CaOH2 can. Okay, so Jingwen wanted to try a calcium hydroxide. This one, if I have to guess the state symbol means what state is it existing? It only can be solid, liquid, gas, or aqueous. What state would you guess calcium hydroxide is? Gas? Cannot be gas. Either solid or aqueous. Okay, y'all wouldn't know. It's aqueous, but y'all wouldn't know. It's not your fault. Okay? I haven't teach yet. Now, the last product is water, and water must be liquid. There's no problem. I want y'all to figure out what is the salt. This is the salt just now. But can you figure out what is the salt for my example? Who can tell me the English name first? English name easier to come out with. Just change it. Just take the partner and grab the name anyway. Take the metal first. Somebody online also can say it's easy. The only available metal is, in my example, Kelly said it already, but I won't say it out. Can somebody else say? Calcium something. Calcium what? Calcium nitrate, right? Kelly and Keith got it. So see, I'm making use of the metal of the base and the anion of the acid haven't used yet. Because if not, how to balance? To balance means all the atoms must show on the other side. So I must make a product of calcium and nitrate. Who can? Okay. Who can tell me the chemical formula for calcium nitrate? Still not easy. You need skills. If you say CaNO3, you're wrong. A lot of kids do that. They just see, oh, here got Ca, or here got NO3, just write together. Wrong. This is very wrong. Who can tell me?
CaNO3 bracket 2.
Ca with the bracketed NO3 too. You all understand what Clary just said? And this is aqueous, you all don't know why. You haven't learned, so I'll just give it to you. How come? How come she knows to do this? Do you all know? Because calcium is group what? Calcium, you can verify. Ca is 2 plus, nitrate is already memorized. Nitrate cannot see it, so it's NO3 minus. Can you see the crisscross now? The 2 comes to the whole nitrate, and the 1 goes here. We're not done yet, we quickly balance it. Y'all can try balancing on your own. If you have no time, next week you can continue. But the balancing, if I'm trying to be fast, is like that. And like that. I'm just doing it very quickly. So I'm inserting numbers in the front to ultimately make all the numbers match. So I figured it's a 2 here and a 2 here. Who is lost? The balancing will spend more time.
Why do you need to write the AQ and the L thing?
Oh, okay, these are called state symbols. This one is not fully taught yet. That's why I told you I'm giving it to you. These are called state symbols.
So
but
L is
very...
liquid.
Huh?
Is L liquid?
Yes. So state symbols can be solid, liquid, gas, or AQ. Only 4 options. These are the state symbols. The ones that we know for sure, like liquid, water must be liquid, we know. But why? How come sometimes AQ, sometimes solid, you haven't learned? So eventually we'll get there. AQ, do you know the meaning of AQ? Who knows or who don't know? AQ means dissolved in water. Okay, copy down first. So in this chapter, every time you see acid alkaline, just straight away bracket AQ. Cannot bracket anything else really. Okay, we'll overrun a bit already. I'll just let y'all go and I will continue from here next week. If you cannot follow the balancing, okay, I'll tell you what, I'll erase the balancing. We'll talk about it next week. Okay, so that we don't rush. Anyway, and we are in good progress. In one lesson, we almost covered all of acid already. So one more lesson, we can cover this chapter. Until page 6 only. Any questions?
Wait, so acids are always dissolved in water?
Acid, the fact that you call it acid, you must be dissolved in water already. If you haven't dissolved in water, look at me, look at our first page. If you haven't dissolved in water, you are still here. Can you call this an acid?
No.
Cannot. You call this an acid. So what makes acid is the fact that it has been dumped into water and water has managed to pull it apart. Okay? So yes, all acids are equals. No such thing as a solid acid. And okay, I'm gonna let y'all go. AMS student, 30 seconds break, can? 1 minute break. I will talk to y'all in 1 minute.